Welcome. Welcome to module 2. The first session is what is a computer? In this session, we'll study what exactly is a computer. And suppose somebody asks you to draw a block diagram of a computer, how you are going to draw it? Now, what are the different blocks of a computer? What are the main parts of a computer? That we are going to study. In this session. Cambridge Dictionary defines computer as an electronic machine that is used for storing, organizing, and finding words, numbers, and pictures, plus for doing calculation and also for controlling other machines. So basically it's an electronic machine. At present it is an electronic machine. Started with mechanical machine. Started as a mechanical machine actually. Consisted of wheels and gears. But of course they were not used for programming. But still it started as a mechanical computer and then electric computer. In those days the computer size was equivalent to that of a room. Now it is a electronic device. It's an electronic device. So the mechanical device is different from electric device. Electric device is different from electronic device. So mechanical device usually consists of wheels, gears, etc. Electric device makes use of electricity, and then the different components will be large in size. So after that, electronic machines, where these different parts will make use of very low power. Electronic machines are basically low power devices, and as the power decreases, as the power requirement decreases, the size of the device decreases. That's why now you can see the computer on your desktop. So it's an electronic machine, and it is used for storing. That means you should be able to store it in memory. That means you keep it somewhere. That is, you keep it in memory, and whenever required, you will be retrieving it and using it. And also for organizing data, programs, etc. So the organization of data has a major impact on programming that we'll study later. And finding, that means finding or searching. So what you store, what you organize, what you find. So you store words, numbers, and pictures. Also, of course, you can say the video. Video is nothing but a collection of pictures. So we consider words, numbers, and pictures. It started with numbers actually. Computers were used to do operations on numbers. The latter started manipulating words also. And now we have pictures, videos, etc. Whatever we can imagine that can be stored inside a computer and then manipulated depending on the requirement. So it was initially used for doing calculation. Computer is very quick in doing the calculations, and for controlling other machines also. This is also one important point. The trend is towards controlling other machines. That means a computer can control some other device. Computer can control a printer. A computer can control a TV, washing machine, whatnot, big CNC machines, lathe machines, etc. Computers are capable of controlling. Though you may not see them explicitly. In case of printer, you see it explicitly, but maybe in case of washing machine, maybe in case of robot, you don't see the computer explicitly, but it is embedded into that one. Device. So you can control the device, the different devices. That means you can decide what it should do, in what order it should do, etc. for controlling. The computer is an electronic machine. So, but please note that in future, it may not be in future it may not be electronic machine. It may not be electronic machine. We are talking about quantum computers, molecular computers. So in future, it may not be an electronic machine. So initially mechanical computers consisted of gates and wheels. So after that, electric machines with main component of that electric machines was vacuum tube. Vacuum tube, main component. There are also computers that are theoretical in nature. There are also computers that are theoretical in nature. In fact, it started with theoretical computer science actually. Theoretical computers. That means they are not your physical computers. They are not your physical computers. They are theoretical computers in the sense that you can imagine a tape. You can imagine a tape and you can imagine some symbols and you can manipulate the symbols to achieve something. So theoretical computer. Theoretical computer can be used to do some calculations. So technically, theoretical computer in computer science is called as Turing machine. Turing machine. So it started with Turing machine. Turing machine, though it is a theoretical computer, but it's still very, very powerful. Still very, very powerful. So the premier institutes, IISc Bangalore and IIT Kanpur are known for theoretical computer science. Theoretical computer science. Now we are moving away from this one and we are more interested in practical part. And transistor is the main component of today's computer, electronic computer. If you take transistor is the main component. Transistor is the main component of the today's electronic computer. What Moore's law states is Moore's law states is the number of transistors that can be placed in a unit of space is going to double every 18 months. The number of transistors is going to double every 18 months. So maybe it started with some 2000 computers, 2000 transistors inside a computer, but so if you take the current computer, say the i7 processor based computer, so the number of transistors in it is approximately 3 billion. Can you imagine? 3 billion transistors. 3 billion transistors. So it's a huge number. It's a huge number. That is in i7 processor only. i7 processor only. Now the processors keep on changing. The technology keeps on improving. Number of transistors is going to increase. But of course, we have reached a stage where we cannot continue to increase the number of transistors. That's why we are thinking about what is called as quantum computers and molecular computers. Quantum computers and molecular computers. So maybe in future we may have quantum computers and molecular computers which are going to replace the current electronic computers. So current electronic computers have some limitations. In fact, if you consider the security, everybody knows what is actually security, cyber security also. The security is dependent on the processing capability of computers. So because there is a limited processing capability of today's computers, the algorithms that are designed and particularly the keys that are designed associated with the security algorithms will be a key. That is the main thing, not just the algorithm. There will be a key. Key cannot be broken. Key is some numeric value, you can say. Numeric value, alphabetic value, whatever it be. So it cannot be computed. Cannot be computed in a quick time by the current generation of computers. So you decide one thing, and if somebody tries to determine the key, it takes huge amount of time. That is the main point here. Using current computers, it's difficult to determine the key that was used by somebody else. So maybe with quantum computers, the current security algorithms are not going to work. We may have to design new security algorithms. So it will be a different ball game. Okay, IBM has designed a quantum computer, though we are at the research stage, but IBM has designed a quantum computer and it has placed it in the cloud. It has placed it in the cloud. You can say cloud is nothing but cloud is usually represented. Why it is called as cloud means it is represented in the form of a cloud. Represented in the form of a cloud. So what that cloud represents is network. So if some resource is accessible over a network, then we use the term cloud computing. That resource can be hardware, that can be an operating system, that can be some software program also. Whatever may be the case, you will be accessing it over a network. If you access the resources over a network, then it is called as cloud computing. Then it is called as cloud computing. So, but maybe it takes more time for the quantum computers to come to your desktop. So today's computers are still electronic computers only. Today's computers are electronic computers only, and they make use of current. They make use of current or voltage. They make use of voltage. So electric devices, if you take electric device, motor, etc. So it uses what is called as alternating current. It uses what is called as alternating current. So we are not getting into those details. The current can be of two types: AC, DC. Alternating current, direct current. Alternating current, direct current. Electric devices are based on AC. Electronic devices are based on DC. Of course, you will be supplying only AC. If you look at the backside of a computer, so you will be taking a plug. You will be taking a plug and inserting into the socket there. Inserting into the socket there. Look at the backside of a computer. That plug will have a cable that will be connected to your power connection. That will be connected to your power connection. From the power connection, a plug comes, cable comes, plug comes, and then plug is inserted inside a computer. So basically you are supplying only AC. You are supplying only AC. But inside a computer, there is one device. There is one device called as SMPS, switched mode power supply. SMPS or switched mode power supply. That switched mode power supply converts AC to DC. Converts AC to DC. And after converting, another point is different components of a computer require different voltage levels. Different components of a computer require different voltage levels. Those voltage levels will be generated and then supplied to appropriate components of a computer. So some components may require say 3.3 volts, some components may require 5 volts, and some components 12 volts. Usually the components inside a computer, if you consider, the maximum voltage that is required is 12 volts. So if you have a DVD drive, hard disk drive, then you have the requirement of 12 volts. Other components may use 3.3 volts and 5 volts. Two important characteristics of a computer are computing and storing. Computing capability and storing capability. Computer should be able to store the content and then do the processing. Here computing means you will be processing it. That means say A and B are the two numbers, or 10 and 20 are the two numbers. So you will be able to store those numbers in the memory. Will be able to store those numbers in the memory, and then if you require, you may add those two numbers. Adding the two numbers, you can say it is processing. So we'll be adding these two numbers to get 30. And again, this 30 can be stored inside a computer. So the data that can be stored inside the computer can be in the form of numbers, alphabets, images, video, etc. Programs stored can run on different sets of data, and also the programs can be modified based on the requirement. Have a look at it. The programs can run on different sets of data. That means if you have say a program, say in simple terms, a program which adds two numbers, then that program can be used, the program can be used to add any two numbers, 10, 20, 3141, 05. It can be any numbers. It can be any numbers. So input can be given and the same program can be used to perform processing on those two numbers. So input is given in the form of two numbers and those two numbers can vary. But same program can be run, and depending on the numbers which you are giving as input, you may get different output. Programs can be modified also. That is another important point. Programs can be modified. Programs can be modified. Programs can be modified. So that means if you have set program which adds two numbers, it can be modified to multiply two numbers, or it can be modified to add three numbers at a time. So like that, you can keep on modifying the programs. You can keep on modifying the programs. You can have different programs. So you can have multiple programs which can perform different tasks. Suppose you can have one program to add numbers. You can have one program to multiply two numbers. You can have another program to divide two numbers. You can have a program to determine whether a given number is prime or not. Like that, you can have multiple programs. Depending on your requirement, you have to write the program and then run it. So this is what makes exactly the computer different from other devices like calculators. So in case of calculator, program is there, but that program cannot be modified. That program cannot be modified. It is fixed. It is fixed. It is fixed. Whereas in the case of computer, that program can be modified. That program can be modified. And you cannot load the new programs into a calculator. But inside a computer, you can load new programs. Why only ones and zeros? You might have heard that computer uses only ones and zeros. Why only ones and zeros? Why only ones and zeros? Why not a decimal system? That means in the case of decimal system, the possible digits are 0 to 9. The only possible digits are 0 to 9. But of course, you can combine these digits to get other numbers also. That means 90 to 925, like that. But the only possible digits are 0 to 9. In the case of computer, it recognizes only two symbols. That is 0 and 1. 0 and 1. So computer, that's why it is called as computer is based on binary system. Computer is based on binary system because binary means only two. What are the two? 0 and 1. 0 and 1. So, but why computer deals with only zeros and ones? Why everything has to be stored in the form of zeros and ones? It is because computers are basically electronic devices. Electronic devices are unstable. Unstable means, so it's very difficult to keep the voltage at a particular point. So 5 volts means it is difficult to keep it at exactly 5 volts. It will be varying. It can go up to 5.2, 5.3, 4.9, 5.0, 4.7, like that. There will be minor variation. So that you cannot prevent. So you cannot have multiple values. Now again, if the voltage levels increases, the size of the computer increases. Size of components increases, the size of computer increases. So you should have only few voltage levels. So it should use only low voltages in order to reduce the size of a computer. But it is difficult to keep the voltage at a particular point. Exactly at a particular value, it is difficult. That's why computers go for binary number system. That is, the only possible symbols or values are 0 and 1. But of course, again, you can combine these zeros and ones as you like. 0, 1 or 1, 0 or 1, 0, 1, 0, 1 or 1, 1, 1, 1, 0, 0, 1, like that. You can combine. Transistor. As I told you, transistor is the main component inside a computer. The CPU or microprocessor. The central processing unit or microprocessor is made up of several transistors. What exactly CPU will study? CPU or microprocessor is the main component, and within that the component is transistor. So transistor is an electronic device that has only two states, on and off. And Moore's law says that the number of transistors is going to double every 18 months. 18 months. And the i7 processor, approximately 1.8 billion transistors. I think this value is when I prepared these slides, but now it is 3 billion. So it is changing at a rapid rate. It is changing at a rapid rate. Approximately 3 billion transistors. Okay. Usually we start with this one. Block diagram of a computer. Block diagram of a computer. It is called as block diagram because it is represented in the form of blocks. And say these rectangles are the blocks. These rectangles. This is one block, this is one block, this is one block, like that. So these rectangles are the blocks. So you represent, whenever we come across block diagram, that means you have to represent that one in the form of blocks. Each block may represent something. May represent something. This is directly taken from commons.wikimedia.org. That's why I mentioned it as source. Okay. Few diagrams may be taken from freely available sources. Wikimedia is one such source where you can find the diagrams of different components of a computer. So we will consider those diagrams, and we are permitted to do so. So block diagram of a computer or von Neumann architecture. Von Neumann is the person who introduced this block diagram, and it is considered because even the modern computers are modeled after this block diagram. Even the current computers or modern computers are modeled after the von Neumann architecture. So how many blocks are there? You have, say, 1, 2, 3, 4, 5 blocks. Total of 5 blocks, and accumulator is within this ALU, arithmetic logic unit. Okay. So if you consider this as a computer, and memory is a place where you store your data on programs. Memory is a place where you store your data on programs. If you want to be specific, you can store your images, videos, etc. also in memory. There are different types of memory that we are going to discuss, but memory is a storage device. Memory is a storage device. It can be what is called as RAM, random access memory. It can be hard disk. It can be your pen drive. It can be your pen drive. It can be many other devices also. Any other memory devices. Okay. Data and programs are stored inside memory. Now the main part of computer is this CPU. Central processing unit. This one is called as central processing unit. I hope you can see the arrow. So the control unit and arithmetic logic unit put together is called as CPU or central processing unit. The central processing unit consists of two parts. Control unit and arithmetic logic unit. And within this arithmetic logic unit, there is one special type of what is called as register. Register is also a kind of memory. So we'll study these internals of a computer later. We'll go into the details later. But accumulator, you can assume that is a fast memory, limited memory that is present inside the CPU. And you have input and output devices. You can see the arrows. Input. That means this device gives input to the computer. Example is keyboard. And the computer produces the output which is displayed on the, or which is sent to the output device. Your printer, your monitor can be considered as output devices. So keyboard is the input device. Mouse is also an input device. And output device is your printer, and your display or monitor. So CPU is called as central processing unit. It is called as central processing unit because inside a computer there will be many processors. There will be many processors. So some specific tasks require a separate processor. For example, a math processor. And there will be processors associated with input-output devices also. There will be number of processors. So one which is used to execute the programs is the CPU or central processing unit. One which is used to execute the programs is called as CPU or central processing unit. So it is the main processor. That's why it is called as central processing unit. Central processing unit. It is the main processor. It is the main processor. So it is the CPU that executes programs. It is the CPU that executes programs. The central processing unit is otherwise called as microprocessor also. When the CPU is reduced to the size of an integrated circuit, IC. So this ICs you can find even inside a calculator, even inside your Walkman, small ICs. Okay. When you reduce the size of the CPU to that of an IC, it is called as microprocessor. It is called as microprocessor. So previously, processors used to come in the form of a card slot, in the form of a card, like this. So may not be of this thickness, but like this. So people used to insert it into what is called as a slot type. But now they are reduced, and they are very small. Small devices. They are very small devices. I don't have at present processor, but they are very small devices. They are very small devices. So CPU executes programs. CPU has two components: control unit and logic unit, arithmetic logic unit. Control unit is one which is used to control the operation of a computer. So what do you mean by controlling? Controlling in the sense that your computer should work correctly. So you should ensure that your computer works correctly. So it is ensured by generating what is called as signals. So there can be different kinds of signals: read signal, write signal. So whenever you want to read the data, you have to generate what is called as read signal. Whenever you want to write, you have to generate write signal. Also timing. Computer is very precise device. It is very fast when compared to humans. So that timing is controlled by a clock, what is called as clock. So now control unit takes care of that clock. ALU stands for arithmetic logic unit. That means it is used to perform two kinds of operations: arithmetic operations like addition, multiplication, division, etc., and logical operations like ANDing, ORing, etc. Okay, we will study about this AND OR in computer organization subject, but we'll study briefly later some other modules. AND operation and then OR operation. Simple terms: AND means whenever something both are true, it will be true. The result will be true. When there are to say two values, one value is true, the other value is also true, then the result of AND operation is also true. So in the case of OR operation, the result is false only if both are false. So keyboard will be there, monitor will be there. So keyboard supply the data to the computer, whereas the display or printer accept the data from the computer. So memory is where the data are stored. The memory can be temporary memory. That means which is basically volatile memory. That means as long as the power is on, its content will be there. Otherwise, contents are lost. So the main temporary memory device is RAM, random access memory. And then you have permanent memory called as hard disk. Permanent memory called as hard disk. So hard disk is used to store the data permanently. So this is the hard disk. See, this is the hard disk. The hard disk. Of course, it will be in closed. It will be enclosed inside some other closer. Will be put inside. It's called as a drive. Inside a drive. Okay, there will be enclosures, cabinets. But this is the permanent memory hard disk. That means its contents are not lost even if we switch off the power. So probably all of you may be thinking that this is the main one, because all your files, programs, images, your photos, your videos will be stored on in this one only. But as a programmer, the main one is RAM. So where program should be present to be executed. It is regarding what is a computer. The computer is an electronic device. It will have different components. The main component is central processing unit or microprocessor. Next, will have memory. Memory can be temporary or permanent. Temporary memory is RAM. Permanent memory is hard disk. So it will also interface or interact with the input-output devices. Keyboard is the main input device apart from mouse. But there are also other devices. For example, joystick is used in gaming. Joystick is there. Okay, something like your gear rod of a bus. Joystick is there. Also, you have different kinds of output devices like printer. The main device is display or monitor, on which you can see the images, photos, videos, etc. Okay. So apart from it, you have scanner, etc. So inside a computer, there will be two main units. Inside the CPU, there will be two main units: control unit, which generates or controls the computer, and the arithmetic logic unit, which enables us to do the operations. The two main operations are arithmetic and logic operations. This is regarding what is a computer. So we'll meet in the next session. Thank you.